I clicked recording, but I didn't.
No, you didn't.
I got distracted. Thank you. I got distracted letting you know that I was starting to record. All right. So then, for the sake of record, let me go back one slide. I'm going to just introduce what we're going to do in this third workshop of the SCOC, discussing the phase 2 SCOC recommendations. And I want to start by thanking the members of the SCOC, the Survey Cadence Optimization Committee, who have been working tirelessly. And I really do mean tirelessly. It's been an enormous amount of work for the past 2 years on optimizing the survey strategy for LSST such that we can get the maximum science throughput from this survey. I want to read their names explicitly to acknowledge them and thank them. Frank Bauer, Sarah Bro, Renee Josek, Mansli Kaslival, Knut Holsen, Rania Paris, Max Schwamm, Dan Skolnick, Colin Slater, and Jay Strader are the amazing members of this committee at this time. Also, Lynn Jones and I sit on the committee as ex officio and non-voting members. And I want to acknowledge and recognize the work of the observing strategy team that supports this committee. Lynn Jones and Peter Joachim, you will see them, they will present to you today. So I put their faces. But also Eric Nilsson and Thiago Ribeiro. Further, I want to acknowledge and thank the community because this is really the work of the community more than anybody else. We have working closely with the community since roughly 2015 to produce this optimization of the survey strategy that we aspire that aspires to make really truly LSST fulfill its potential. There have been literally hundreds of people involved in this process that have produced white papers, cadence note. We have provided the opportunity to publish some of those papers as peer-reviewed papers. So there have been peer-review articles appearing from this work. On the right side, I always like to show this diagram of the 48 white papers that came out in 2018. Each dot is one paper, and the size of dot represents the size of the size of the authors pool. And the connections represents the connection between authors that have co-authored different papers in this process. And the color represents the science collaborations. Most of these papers have been nursed within the science collaboration environment, although we had contribution from other groups, including surveys, groups interested in other surveys that are synergistic with LSST. As I said, the process has begun in 2015 and has been going on since with various modality and ways in which we have connected with the community. It started with the concept, the white paper that was designed to be a living document where primarily only science collaboration members were involved. That had 54 contributors on GitHub. I suspect more people have actually worked on that paper. In 2018, you all produced the 48 white paper. There were 467 unique authors of those papers. And in 2021, the cadence note, there were 218 unique authors of those papers, obviously largely overlapping with the other two groups. And this is truly a pioneering process. No survey before has worked this closely with the community in this extremely complex optimization process of a multi-purpose, multi-scope survey. Of course, that also means that we have been building the plane as we were flying. And the process has been non-linear, sometimes more than others, and will continue to be non-linear because we are still in uncharted territory, but we're working very hard to try and streamlining and make it as productive and as productive and accessible to everybody. The number of simulations that have been produced for this project, so these are all possible realizations of the LSST survey, is also staggering, and I want to emphasize that. We started with 14 simulations at the COSEP, 16 for the white papers, 173 for the cadence note. After that, we have produced another 300 or so simulations, and we really means the observing strategy team, which we are now trying to collapse onto a single simulation. Of course, the Rubin sim environment has been vital to this process, and I want to acknowledge all the contributors. The Rubin sim is an open access environment for simulations and interfacing with the simulations of the LSST strategy. So that includes the operation simulators that produces the simulations that I mentioned, and the math framework that many of you have worked in that allows us to evaluate a science case against a particular simulation. The product of the math, for the most part, the products that the SCOC looks at are plots like the one that you see on the side. We use your science metrics, your maths, along with system science metrics that are certain that our process is consistent with the requirements, with the technical requirements of the survey. And we compare the performance of this large set of metrics against different opsims. Of course, the metrics benefit from different survey designs, both the scientific metrics and the system metrics. So we're never able to optimize all of the metric at once. As we optimize some metrics, some will take a hit, and our job is to balance this optimization process in the interest of producing the overall best science for LSST. In this process, I heard Željko many times referring to as minimizing unhappiness as opposed to maximizing happiness. I really do think that we are trying very hard to work on maximizing happiness, and that we've made tremendous progress on most science cases, improving the survey tremendously since the start. We're obviously bound by survey requirements. We know that the survey will take about 850 images over 10 years, over 18,000 square degrees. But the details of how we do that is what we are optimizing. And that leaves a lot of space for science throughput to be impacted by these details. A visualization that I always like to show about this is this one. This is a key parameter for a lot of transient science, which is my science domain. It's the time gap between observations. And you see that in different filters for different rows. And you see that for two different simulations of the LSST. So I don't want you or need you to look too deeply into this plot, but just to see how different the distribution of time gaps across the sky might be, given some choices, and both these sets of choices fulfill the high-level requirements that are expressed in the surveys, in the SRD document, the survey requirement document. In the past, going from the initial survey, going from the initial survey to the survey that was recommended by the SCOC through the phase 1 implementation of its recommendations. We have made many changes to the footprint, to the way in which the sky is observed. On the left, you see version 1.7, which is where we started with the white papers. And then now you see version 2.1, which is where we landed with the last year's recommendation of the SCOC. So rewind by about 1 year. And today we're describing how we're moving forward from the plot on the right. The version 2.x, so 2.1 and 2.0 and 2.1 of the survey strategy have, as a baseline, already improved the science throughput on a very large number of science metrics as produced by you. Like I said, some science metrics will take a hit as others get improved. This is another way to see the performance of science metrics against an opsim. Here, red and blue are two different opsims, and each corner of this radar plot is a metric that primarily metrics that you, the community, have contributed. And the further out a point on an angle is, the better the performance of the metric is. I want to highlight one thing, that the way in which we look at these metrics is relative. We typically look at the improvement compared to our previous baseline, our previous default for how we would run LSST. So here you see essentially version 1.7, it's a version 2.0 retro baseline, so essentially it reproduces version 1.7. It's a perfect circle because that's our baseline for comparison. And then you see the performance of the different metrics in the updated baseline 2.0 survey. Based on your feedback, we have produced about 500 simulations in version 2.1 and 2.2, which we have looked at, and they address rolling strategies, whether to include triplets in observing, so what is the time gap between observations on the same field, whether to vary exposure time, how to implement and which microservice to implement, including targets of opportunity, and an overall refinement of the footprint, both on the low extinction and the high extinction areas of the sky. All these things have been optimized. And I guess I can skip through this. Thanks to your input, which came in many forms, including reports that you've written to the SCOC, your direct line to the SCOC, which are your liaisons into the SCOC. Every science collaboration has one, as well as community posts and discussions and points of contact during meetings like the PCW. We're trying to collapse about 500 simulations into one. At this stage, we have been able to release a very small subset of simulations that represent the range of our recommendations as they stand today. It's 4 simulations. We intend to move into 2023 with a few simulations, not necessarily these 4 simulations, but these represent today with, and you'll hear a detailed description of each one of them and how it represented and how well it represents the recommendation of the SCOC, the current status of our recommendation. Why is it 4 and not 1? Because our recommendation today is not final. We have some parameters of the survey over which we have a really good handle, and we have a recommendation that we believe is final and might be tuned by perhaps very small amounts. We do have key parameters of the survey that still require work and optimization, both because we might not have the all of the information that we need to finish this optimization, or because they're interlocking parameters that we are trying to jointly optimize. And you will hear all about that from Lynn and Peter in a minute. So we're in the timeline of the phase 2 work of the SCOC. This is where we are. The SCOC have been receiving simulations over time, starting in November last year, all the way through the summer. We have constructed a set of recommendations, which we have already presented at the PCW. And then we have turned those recommendations into the 4 simulations that we have shared with you on community about a week ago. I want to emphasize very strongly that we did not expect that you have already looked at those simulations, made up your mind about whether they're good or bad and what should be changed. That is not the purpose of this meeting. Today, we present these simulations to you, and we want to help you beginning the process of analyzing them and talking to us about your impressions of them and help us optimize them further. For that purpose, I thought I had a link somewhere here, but I don't have it. But in this community post, Lina has also produced a notebook where the majority of the science, where a large set, there's so many science metrics. There's 1,000 metrics that are kicking around. So, but a very large subset of those metrics has already been run against these 4 OPSIMs and the previous baseline, so that you can directly compare the output of the metric without having to run it. And that is linked in the community post. I believe I put the link on Slack as well, but if not, I will put it just as I stop speaking. Finally, let me just tell you what we're going to do today and tomorrow. So a quick look at the timeline. I'm done with my introduction. I will pass the microphone to Lynn and Peter to present our phase 2 report. We haven't produced a report yet, but to present our recommendations to you, why we make the recommendations, what the recommendations are, and why we have converged towards the recommendations that we have converged towards, and which ones of those we think are in a final stage, which ones of those we're still working on. Peter will present the simulations themselves. We'll have a Q&A about these presentations. We'll have a break. And then we wanted to make space for you. And then we'll talk a little bit more about the specific simulations and how they compare to the simulation, to the earlier baseline and the earlier simulations. But then we wanted to leave some space for you to get together as groups, as science interest groups, whether that's science collaborations or some similar configurations, and talk about these simulations that we have presented to you and look at the notebook, and you will have the help of the liaisons into the science collaborations to guide you and ask questions in small groups. Tomorrow, I want to introduce and discuss a bit how the work will continue from now through 2023 and the beginning of the survey. I will introduce the new member of the SCOC. We have a turnover in December for about a half of the members of the SCOC. So I'll introduce the new members of the SCOC, those who are here, and I will name the ones that are not here. And we'll talk about how the process of interplay between the SCOC and the community will function from here forward. We'll have space for community feedback, both in an informal setting for however much time in the morning is left. And we would ask the people that join breakout rooms today to communicate reports from the breakout rooms tomorrow, whether those are formal presentation with slides or more informal presentations. That is up to you. We don't want to put a burden by specifying the format, but we want to hear what your thoughts were, what your thought as a group in the breakout room were. I think that was my last slide. And with that, I can look if there is anything to take care of on Slack or Zoom, and otherwise pass the microphone to Lynn.
Thanks, Fred. Let me figure out how to get my screen all shared properly here. Okay, and I don't usually do this from Google Slides, so let me make sure I can actually put it in full screen view, full screen, and you probably can't see that anymore, right?
Looks good.
Don't see the full screen, but we see the slides.
That's what I thought. Yeah.
If you remove the presentation,
afterwards, didn't I?
In the meantime, I'm going to take the chance and say, I think if the questions, I will leave judgment for people to ask questions the way they prefer, whether they think that it can be answered directly on Slack or they want to ask it out loud. We'll let Lynn go for her presentation and maybe just interrupt if there is something that is really critically impairing your understanding. Otherwise, leave the questions for the end of the presentation. And I will get to the questions that were asked during my talk on Slack.
You know what? I'm sorry. I'm not sure I can actually figure that part out. And I know I've had this problem before. If somebody wants to tell me, view the slideshow. Oh, okay. Let me try that instead. Sorry. Slideshow. Thank you. And now, do you see it or did it go away?
Yes, now it's perfect.
Okay, perfect. Thank you. Thank you very much. Okay, so yeah, I've been asked to run through the phase 2 recommendations. I'm going to run through these relatively briefly, and this is on behalf of the SCOC. So I would like to say thank you very much to the SCOC. I know they've been working really hard on these recommendations and coming up with going through the task of looking at all of the survey simulations and the metrics that we have and talking to the science collaborations and trying to figure out what's the best combination of survey strategy choices. And it's a complex task, and we're working on that. So the phase 2 recommendations, so these are the things that are coming out of the V2 series of simulations, were formulated as a series of 8 questions following up to the phase 1 recommendations. And I put these a little bit out of order here. There were 8 questions that were numbered 1 through 8, and I've rearranged them here to show sort of where I think that there's a little bit more certainty in the recommendation, where there still is maybe a little bit more work to be done. So we'll go through these. There's early science, micro survey recommendations, the target of opportunity time, the filter balance, footprint refinements, and then the intranight cadence, which while it did include a variety of different options, is kind of narrowed down to what should we do about triplets, and should we do triplets, the rolling cadence, and deep drilling field strategy. So early science, the early science questions are very intertwined with commissioning and template generation based on early science white papers that were submitted as part of the call for information about early science. Because this depends on a lot of the things that we don't necessarily have a very good handle on yet, because of commissioning and template generation information, most of the work on this will be done in the next year, 2023, after the phase 2 recommendations. So for now, I would recommend people going to look at RTN 11. There's a link there in the slide here. This is an LSST document that's talking about early science. And there's also an early science area on community.lsst.org. And Melissa Graham is here today, and she's organizing a lot of that early science work through the community. So basically the answer here is there's no recommendations at this time. And this will be addressed in the 2023. So that's nice, very, very, very sorted. The next question is microsurvey recommendations. So microsurveys are special observing surveys that require a few percent of LSST time. With the consideration that there's a lot of uncertainty in observing efficiency around the start of operations, things could break. We can't make the decision on 2 by 15 visits versus 1 by 30-second visits until we have commissioning data in hand. The SCOC made the choice to recommend the minimal microsurvey commitment in year 1, which I think is really smart. It takes a lot of the pressure off, like deciding how much time to commit to microsurveys in year 1. And then once we get a better handle on what the observance efficiency is like, if we have spare time, if we actually don't, because things are less efficient in operations than we expect. I don't anticipate that, but it's a possibility. Then the commitment to microsurveys can happen when we have a better idea about that. They did decide that in light of that, to only prioritize microsurveys that have a requirement to start in year 1. And in general, we're looking for microsurveys that take advantage of Ribbon's unique features and have a significant scientific benefit. So at this time, they chose 1 microsurvey to prioritize, the Twilight NEO microsurvey. And in our 4 simulations that we have here as part of V2.99, we've implemented that as observing in RIZ bands, 15-second exposure per visit, active every 4th night. Due to a little bit of oversight in how the run was set up, we're currently only using morning twilight and only using a fraction of that morning twilight. And so it's actually an extremely light microsurvey in the current setup. I think this is not terrible, but we clearly still need to look at this and do some more work. So we'll talk about that a little bit more later, but that's the idea, that the recommendation was RIZ exposures, active every 4th night, and using actually both morning and evening twilight. If observing efficiency is high, they could potentially add the Northern Stripe microsurvey. This is a microsurvey to get visits in all bands at above the standard declination limit for the survey. And they would like to add a new call for micro and nano surveys after the start of operations. The details of that call are not finalized yet, but I expect that that's something the SCOC will be working on. Next question is target of opportunity time. This is actually somewhat uncertain and yet also perhaps somewhat certain. The fraction of time available for TOs is uncertain, but to some extent, if the observations fit into the general observing strategy for the main survey, then the target of opportunity observations aren't necessarily a big impact on the observing strategy after 10 years. That's not to say it might not be a big impact within a 1-year timescale, and it does make a difference what the observing strategy is. More definition on this will happen in the next year when there will be a workshop to consolidate the target of opportunity goals, trigger conditions, follow-up strategy, and we can get a better idea on how much of an impact that's actually likely to have. The recommendation is likely to be to use about 2 to 3% of time for TOL follow-up, but that does depend on the strategy. And there's likely, I would imagine, to be different envelopes for different kinds of follow-up. For example, a trigger that needs a lot of very deep follow-up on a very short amount of time, those may be less frequently allowed to make a less impact on the overall survey. But we will see and see what the workshop shows that we need. The recommendation is to prioritize overlap with LIGO Virgo, which does mean that the first year of operations is probably lightly impacted anyway, because there's not, assuming we still keep to our current schedule, the first year of operations does not sync up with a heavy observing season for LIGO Virgo. They do recommend to continue to keep in mind that there are target of opportunity targets which may not arise from gravitational wave triggers, and we should keep flexibility to respond to those. We did not implement target of opportunity targets in the current V2.99 simulations, but we will likely do that in shortly. So once we get a little bit more feedback from the SCOC. Okay, so that's both. That one is both like potentially uncertain and potentially certain, because we don't know that much, but it might not have much of an impact anyway. So the next question is the filter balance. The general recommendations here from the SCOC were that the general filter balance is pretty good. Maintain the filter balance in the low dust, wide, fast, deep. The exposure time should be maintained as these sort of standard exposures instead of doing variable exposures or changing the exposure time. Now, I would add a caveat to this, that these may need to be slightly modified when we have more information about the sensitivity of the as-built system. So, for example, you can't keep the current filter balance in co-added depths and the current exposure times if the sensitivity in R band is much higher. If the balance between the sensitivity and the different filters changes significantly. So there's likely something that we'll be having to look at here as we get more information through commissioning. I don't anticipate there will be very large changes, however. The filter balance in the galactic plane region and the South Celestial Pole may require additional fine-tuning. And as far as the footprint goes, the V2.0 footprint is close to optimal with the current system performance. And the recommendation was the time spent on mini surveys, that's the northern ecliptic spur, the galactic plane, the South Celestial Pole, was a reasonably appropriate. And here, though, the detailed footprint within the galactic plane may need additional fine-tuning. And so this is the thing that ties both of these questions together, is the filter balance and footprint within the galactic plane. This shouldn't have that much of an impact on the rest of the survey if we can keep the time spent on the galactic plane mini survey roughly constant. And one of the things we've done in V.2.99 is update the galactic plane footprint and filter balance to be closer to what we think to what we've heard from the galaxy science community. That's the combination between the TVS and local volume Milky Way groups. Now, one thing we do see is that we may need to, with our new footprint in the galactic plane, we may need to tweak that footprint slightly to redirect some of the visits. And we may also need to change the filter balance. We had some, we gave up the galactic plane, the galaxies group, a rather limited set of filter balances to choose between. And I think actually they maybe want something a little bit more intermediate. And so we have another round, I think, to go through with them on that. But it is, again, very close. There's actually not that much variation that we could still necessarily include. But this is why one of those simulations in the set of 4 does have quite a noticeable variation in the galactic plane footprint. And that is this low GP simulation. And that's there to emphasize that this is one of the areas that we still have some uncertainty in the what the recommendations are and what they will impact the survey. Okay, I thought I had put in some slides showing the rolling cadence and internight cadence separately, but I did not. Okay, so considering separately, the recommendations for the internight cadence come down to triplets should be added with long gaps, more than 4 hours on a low fraction of nights. The SCOC would also like us to boost visits at 1-day intervals. And then a rolling cadence is recommended. So the 2-band roll early is preferred, but 3-band had some advantages near the 1-day intervals. And so this is where these become sort of intertwined and why I actually have this slide containing both of these points. Because when you're looking at observations over a wide range of timescales, there is some interplay between choosing a 3-band rolling cadence versus a 2-band rolling cadence and some of the other tweaks that we put into the simulation, such as the suppress revisit function, which removes visits from the same night. So what we've done in V2.99 is in this set of simulations, there's always triplets with these long gaps, 4+ hours, that are happening every 6 nights. This isn't very frequent, but it's there. And so we're boosting the number of revisits within the same night at these longer intervals. We also have a 2-band rolling cadence at 0.9 strength in all of the simulations. But in one, there's a roll early simulation, which is coupled with fewer revisits on the same night. And another one where we roll after full season on the sky in a uniform cadence, which has slightly more revisits in the same night. It has a lighter weight on that suppress revisits function. So that's showing another of the areas where we still have some uncertainty. And then the final area where there's actually quite a bit of uncertainty, I think, is in the deep drilling field strategy. The standard deep drilling fields take visits at 5% of the overall survey time. And the recommendation from the SCOC is that we should increase the fraction of time that is spent on deep drilling fields. And also, I think, to change the cadence. So the choice of the new cadence is in progress. It looks to me like the choice of the cadence may affect our fraction of time slightly. Again, these are small variations, though we're not talking about a very large variation. We're talking about the difference between 7.5% in the deep drilling fields versus 5%, potentially. The other recommendation that the SCOC had was that achieving 10-year deep drilling field depth in Cosmos within the first few years was highly desirable as a pathfinder for a lot of the deep drilling field processing work. So in all of these 2.99 simulations, Cosmos reaches 10-year depth within 3 years, and then it continues to take observations on the standard cadence for the rest of the fields. In almost all of the runs, the deep drilling field fraction of time is 7.5%. But deep drilling DD6 that run takes 5% of the survey time for deep drilling fields instead. So this is trying to show an additional place where we have some uncertainty. So this gives us these 4 draft simulations that are attempting to incorporate the SCOC recommendations and also show where there's some uncertainty, in particular in the DDF fraction and strategy, the rolling cadence and the internight cadence, and the galactic plane footprint. In general, the footprint looks more or less like the nice plot you have in the middle of the screen. And now I'm actually going to hand over to Peter to talk more about the actual simulations.
Should we pause for a minute to see if there
Yeah.
are any timely questions? We will also take questions for you after Peter's presentation, but if there is anything before we dig in deeper into the simulation that anybody wants to ask, that they have asked on Slack, but they haven't gotten a sufficient answer to. Both Peter and I and members of the SCOC have been working on answering questions on Slack, as well as Ruben, as Ruben members. I don't see it. Oh yes, Meg.
This is all a great overview, but it doesn't necessarily, I guess wearing my Solar System Science Collaboration co-chair hat on, this doesn't necessarily tell me how you all made the decision. And so I'm wondering if you can talk a little bit about how do I know if my favorite metric was looked at by the SCOC / what happens if I have my metric and I'm worried you didn't look at it or didn't interpret it correctly? Where can people go to get that? Or can you explain a little bit more? Because we've talked about it's sort of relative a baseline, but is there somewhere you can go or a notebook you can look at to sort of check that your favorite metric looks the way it does, or what was the SCOC really looking at? Might be helpful.
Right. So I should I didn't include I think first of all, you're right, this is a very brief overview. I only had 30 minutes, and if I was going to talk in more depth about all of the options, I think it would take well, probably at least more than an hour. But the question about whether the SCOC, so the SCOC addressed the questions of the recommendations by splitting into subgroups. And then each subgroup was tasked with, okay, well, here's one of these questions. Can you go and investigate it? For each of the questions that the subgroups had, as much as possible, I pulled together a notebook that addressed that question, included the simulations that were related to that question. And then, and these are out of the V2.0 and 2.1 and 2.2 simulations. So these here, these V2.99 are sort of the outputs after that, right? So using those range of simulations in 2.0, 2.1, and 2.2, I put together a notebook for each of the questions and ran through that notebook with the simulations that were relevant and with a much more in-depth set of metrics than are shown here, obviously, because I don't really actually have any metrics in this talk. And I'll show a few later on, but still not as in-depth as those notebooks contain. And while there are even more metrics from each science collaboration.
You need a heat map as an example?
Yeah, here, let me.
Or if you want to just link the notebook, I just think giving some insight in that, or
yeah, I will do that in the
it's very small subset, so that would be great if you could just link it. I think your summary is fine. Just understanding that process and that people can go look at it, I think is helpful to know. Thanks.
I will do that in the in the Slack too. Okay. But there's a repo that has notebooks that address each of these questions. And then it's true that there are more metrics for each of the for each science case that maybe didn't get to that notebook level, because each science collaboration has a lot of metrics and not all of them are things that they actually wanted the SCOC to consider. as you know, being on the SCOC also, there's a lot of metrics, right? So where possible, either I took feedback that the science collaborations had written down to say, these are the metrics we believe are important. Or I went and I asked those science collaborations, what are the metrics you think are important? And so as much as possible, the metrics that the science collaboration said, these are important for our metric, for our science, are the ones that are in those bigger notebooks. And so what Fed has here is an even like higher level from that. So it's kind of like you have at the science collaboration level, there's some notebooks which show all of the metrics in groups. As much as I could group them together for that science case. And then there's a metric that's like, here's this particular question, and here's a subset of the metrics from each science collaboration. And then there's even a higher level, which is like, hey, here's something that kind of tries to encapsulate across all the science cases and all the metrics in one plot. What is the advantages and disadvantages? And this is what Fed has here, is that final level. But yeah, I will go and I will put them in the Slack. My goal is to turn those notebooks that I will link in the Slack into put them in a different repo and make them easier to read, so that that's like the background information for the SCOC report. And I just have not finished that yet.
But yes, so all the notebooks, I want to take the chance to really thank Lynn, because not only she has worked on the maths and on the options, but also on producing these notebooks and that sharing them with the SCOC, but also with the science collaborations and looking for their guidance in composing them. And so you find these kind of plots in the notebooks. You also can use the notebooks that are obviously publicly accessible to you. You also can use them and modify them for your needs to include metrics that might not be there, or different versions of the metric, or group them differently. And I wanted to add one thing to the process as you described it. The subgroup were tasked to produce a preliminary recommendation corresponding to a question. Those recommendations have then been reviewed by the entire SCOC, and the recommendations that we present today have been seen by all of the SCOC, not only by the subgroups. Are we ready to go with Peter?
Sure.
Rachel Malba, I see your question. We'll try to answer it on Slack, but also feel free to ask it at the end of Peter's recommendation. We'll go back to it.
Okay, so let me go ahead and go into some details of what's going on in these simulations so that you know what's going on. So I always like to do just a brief reminder of where we are. So this is what the footprint of the simulation looks like. That's the number of visits across the sky. So it's about 2 million visits total. And all our different regions, we've got North Ecliptic Spur, a dusty plain, the bulge. We've added a few other regions of interest in the dusty plain that are observed like the bulge, low dust, wide, fast, deep, 5 deep drilling fields. And on the low dust, wide, fast, deep, we've stuck on the LMC, SMC, and the Virgo cluster. And then down here is the South Celestial Pole. So those are kind of our roadmap. Some of the notes, the NES is only observed in GRIZ, so no U, no Y. It's mainly on there to pick up solar system objects. We've got fewer observations in these dusty regions because we just can't see as much. So, and also fewer regions in the South Celestial Pole because it's always at higher air mass. Some of the logic behind the footprint, you'll notice the DDFs are clustered in right ascension. So this region is pretty oversubscribed. And so that's why the wide, fast, deep has this little notch down and then goes back up over here. That's kind of, we're taking this area that would be good low dust region and putting it into the DDFs. So this is how we can maintain uniformity across the entire low dust, wide, fast, deep. If we tried to go up higher, then we wouldn't have enough visits here and be overdense here. So this is just how we maintain uniformity. Anything else? Oh yeah, that's the, yeah. So that's what's going on there. All right, so how we schedule this, scheduler is kind of a misnomer. I call it more of an artificial intelligence, because really we're making decisions in real time for where to point the telescope. So, and now our process has grown. We used to have a 3-tier decision process for 299. We are now up to a 6-tier process that the scheduler goes through every time it wants to make an observation. So first it says, do I have any deep drilling fields I want to do? If there are no deep drilling fields, then it says, should I do observations with long gaps? Do I want to get a triplet in the night? If it doesn't feel like doing a triplet, it says, okay, I'll observe a large contiguous area on sky in 2 filters separated by about 33 minutes. If there's not enough time for that, it'll say, or if it's starting to be twilight, it'll say, okay, well, let me do a smaller contiguous area in 2 of the redder filters separated by 15 minutes. So those will be better in twilight time. If we don't have enough time to do that, or otherwise we might do high air mass observations to get NEOs and inner solar system objects with 15-second visits. And if all else fails, it will collapse down to a greedy algorithm that just selects 1 observation at a time. So, and in our current simulation, all of these execute at some point. So that's our decision tree. So let me talk a minute about deep drilling field scheduling. For a long, long time, we had a placeholder DDF scheduler in there that was, it took a lot of observations, but they weren't particularly intelligently distributed. Now we pre-schedule all of our DDF observations. We look at each DDF position on the sky and say, when do we expect the depth to be particularly good? When is it in season? When is it off season? And we can define the cumulative number of observations we want as a function of time, and then schedule when those are actually possible. And so here's what it currently looks like. This blue curve is Cosmos. We mentioned how we want to get to the 10-year depth rapidly. So we have a couple seasons of very, very high cadence Cosmos observations. So early in the survey, we get Cosmos extra deep. This lower curve is the Euclid field. And so this is actually 2 overlapping ones that have half the number of observations of the other 3. So we've kind of broken things up here. And Euclid, the Euclid pair has been recommended by the SCOC as the 5th official deep drilling field. And so we have a lot of freedom. As long as we don't radically change the number of total observations, we can change, as long as these curves end up at the same endpoint, we can fiddle around with their slopes a lot. There's a lot of freedom. They don't really impact the rest of the survey that much. So we can roll these other ones. We could have, you know, a double season and then an off season on some of these other deep drilling fields. So there's a lot of details that we can play with independently to refine the deep drilling fields, but they're working much better now. Oh, look, and I already said it. So, but yeah, so as long as we don't try to add many more observations to the deep drilling fields here in the oversubscribed regions, we have lots of freedom. All right, we do rolling cadence. Here is a plot of, I think it's night's year 3 to 4. And so this is what we mean when we say rolling cadence. There's some areas where we take many more observations, some where we do less, and the next year this pattern will flip and it'll fill in. So after 10 years, it looks the same as if we hadn't rolled, but this way we get some nice higher cadence observations of all the transients in this region and skip other parts. Our default right now is to roll with half the sky. So half the area of the wide, fast, deep is getting high cadence and then it'll flip. We've done experiments with a third sky and so on. Unfortunately, we call it 2-band, but you'll notice that they're actually 4 bands, but we call it 2-band because it's half sky. We can add rolling to the bulge. That was a question on Slack, but and that doesn't really impact the rest of the survey. So if we want to roll in the bulge or even the dusty plain, we can do that it'll have a pretty minimal impact on other parts of the survey. And the other thing I should mention is currently we do 3 rolling seasons. So we always start with a kind of uniform cadence across the whole sky because we need to build templates in the early part of the survey anyway. But then after that, we can either do 3 or 4 seasons of rolling. So we'll either end the survey with 2 years of constant uniform observations or just 1 year. So there's not a lot of downside to adding an extra year of rolling if rolling is a big science boost for people. All right, one of the newer things we've added is trying to get observations that cover this kind of 2 to 7 hour time gap. In our previous baselines, we really had very few observations looking at 2 to 7 hours. And so what happens early in the night, and I think we said this was every 6th night, the scheduler will tip over and take observations at high air mass, and then later in the night, several, 2 to 7 hours later, redo that region once it's risen and set a little bit. And so here's what it looks like on the top in RA deck space. So we don't actually cover the whole sky. We don't get the whole sky with 2 to 7 hour gaps, but some parts of the sky get lots of 2 to 7 hour gap observations. So we can decide if we want to try to smooth this out a little bit more, refine this, but we are getting this time scale sampled now that we weren't before. All right. Oh, and here's our inner solar system NEO object survey. So this is taking observations in quads at very high air mass. And there was a slight bug because this is the first time running in a full 6-tier simulation. So that there should be another ring over here on the right. Made this plot yesterday and was like, uh-oh, that's a bug. So it's good we have these meetings because it makes me make all the plots. So these execute every 4 nights. And the good news is this one took about 19,000 observations looking for these objects. And so if we stick on the west and increase that enough, it's about a 0.5% change in the total number of visits. So, and these are the lowest signal to noise visits. So fixing this bug will have a minimal impact on the rest of the survey. So, if you look and your science looks good, adding more NEO observations almost certainly won't impact you. We did some simulations turning down the deep drilling field fraction. So I think the highest one was 7.3%, and we went down to 5.15%. And this is mostly just fiddling with SRD numbers, where one of the magic numbers is the median number of visits in the wide, fast, deep. And so, if we have our baseline, it's kind of down at 792. If we turn the deep drilling fields down, we can get that up to 810. And that's just that tension in that oversubscribed region. Again, if we turn down the DDFs, we do improve the wide, fast, deep a little bit. All right. We have this low galactic plane simulation where, again, it was just turning down the galactic plane a lot. This is probably way too much, but it gives kind of an upper limit of how much we could improve the wide, fast, deep depth at the expense of the bulge. And the answer is not a lot, because we can't move observations from this right ascension all the way over here. So it's some improvement, but not a drastic one. But so we can spin both those knobs. What else do we got? We have a roll early simulation where this is doing the 4 seasons of rolling rather than 3. So this does mean that some parts of the sky will not get a full year of observations at uniform cadence at the start, which has a very small impact on things like proper motions. But if LSST runs longer than 10 years, that penalty goes away. So, and again, rolling early and rolling for 4 seasons or 3 seasons look almost identical, pretty much identical after 10 years, because the rolling all cancels itself out by the end. So static science after 10 years is completely agnostic to how often we roll, hopefully.
But we should emphasize that we are looking at the sensitivity of static science before 10 years to make this decision.
Yeah, yes, it does mean that we won't have uniformity until slightly later than before. One of the bonus simulations that people haven't mentioned yet was we did run something using a bulge footprint from the TVS Milky Way group. And this was kind of this was the initial draft. And then I updated it to draft connected, where I kind of just with a cartoon drew in the current footprint, mainly because if we use a footprint that looks like this one on the left, regions are disconnected, and that makes it harder on the scheduler. So just puffing them up a little bit makes it much easier on the scheduler to run efficiently and do neighboring visits all the time. So so we do need to we can puff this back down a little bit closer to the left as long as we leave it connected. So there's very fine tuning of the footprint that we should do. And now we have a placeholder in the code that we can just go and do that fine tuning with TVS and Milky Way. All right. One more thing that was requested, another bonus simulation, is folks wanted more Z-band observations in the deep drilling fields, because with our new deep drilling scheduling, it does a much better job of executing the deep drilling fields in dark time. And one of the side effects of that is in dark time, we have the U filter loaded and not the Z filter loaded, because we can only hold 5 filters at a time. And so that means very few Z-band observations were getting executed. So if I draw your attention to, you can kind of see I'm plotting over a single year, the color coding is what filter is loaded in the telescope and observing. You'll notice these diagonal lines, and that is Cosmos. Cosmos is just executing almost every single night because this is one of the high cadence Cosmos years. And so in our baseline, this red streak it's always executing wideband observations. If instead of always swapping out Z, we sometimes swap out Y, then you come over here and you see orange and red together. So we can do this. And my first pass look is that it doesn't really impact the rest of the survey. We don't change the co-added depths on the filters. There's still enough time for wideband to execute when we put it back in. So this is a potential for filter balancing the deep drilling fields, we have options that we can refine and not impact the rest of the survey. Okay, so the trade-offs, decisions, and refinements that we still have to make after this round of simulations is kind of the DDF fraction and the fine-tuning of that. The bulge footprint details, it looks pretty good right now. We can, very small refinements made to it. The South Celestial Pole filter balance. Really, if anybody is dying to do science in the South Celestial Pole, please tell me, because we really don't have anything that constrains it. If I cut the South Celestial Pole completely, I'm not sure many people would notice. And so it'd be good to know who would notice and how we can measure that. Some of the rolling details, the number of seasons, if we want to roll in the dusty, wide, fast, deep, or in the bulge, and debugging those solar system observations. And in the next round, we'll go back. We have simulations that include target of opportunity, but we didn't get to include them in this round, but we'll put those back in for 3.0. And just to show, and last night I did debug those NEO observations. So we already have a simulation that has those NEOs fixed. So if people really want to dig into NEOs, let me know and I can give you that simulation so you can see that the inner solar system objects in NEOs survey works. Okay, thanks. Any questions?
Before the questions, Lynn, do you want to clarify what you put? You want to iterate what you put in the chat?
I was just going to say, we do actually have a metric that deals with the South Celestial Pole and to some extent deals with the South Celestial Pole filter balance, because we have a local volume dwarfs metric from Jeff Carlin, thank you very much, which specifically targets the South Celestial Pole and the number of local volume dwarfs we'll find down there.
That's why
I think Knut in the chat is mentioning roughly the same set of metrics and interest. So we're not cutting the South Celestial Pole was never in the planning. Please do not.
Yeah.
That's more saying, like, if there's a bug that it got dropped, I might not notice looking at the pipeline. That's definitely my concern.
We would notice it because of this metric, and that is actually one of the ones that's in the high level metric mesh that the SCOC gets at the final.
I've lost track of the number of metrics. I didn't keep track that metric was added. Okay, thank you.
Yeah.
All right. Questions, please raise your hand. Otherwise, I will also call on people that have asked questions on Slack. I wanted to bring up the question that Rachel Mandelbaum asked, because it's really critical to understand what it is that we're doing here in the next 2 days and what we're going to do in the future. Unfortunately, I think she had to drop out. Rachel, unmute if you didn't have to, but you said I'm going to drop out in 2 minutes, and that was 5 minutes ago, unfortunately. So I'm going to read the question from Slack. I have a question about the degrees of freedom Lynn mentioned, for example, the deep drilling field fraction, rolling cadence, and intranight cadence interplay, where there is still some uncertainty in the version 2.99 simulation. Is the goal to answer this question with version 3 and include this answer in the phase 2 recommendation, or do you anticipate some of these being addressed next year? I will stop reading the question here to emphatically say some of this will be answered next year. We do not aspire at this stage of answering all the questions right now. For some of them, we need additional information, including to better understand how the deep drilling fields internight cadence can be performed to really maximize the science that is interested in the deep drilling fields and that is pushed forward by the deep drilling fields. And those that have an interplay of multiple parameters are harder to optimize. So we may need a longer path to actually really fine tune joint parameters. So we do expect that some of the questions that Lynn has listed that are still open might resolve before December with your help, but we do not expect to resolve them all before December. So this is not a call for giving us the answer right now. That's not what this workshop is about. Are there any questions for Lynn or Peter on the simulations? We have about 10 minutes before the scheduled break. There's a question on, but yes, Will, I saw your question on Slack. I think it can be answered briefly, so perhaps go ahead.
Just what the question says, for those of us who might have lost track of the rolling notebooks, I think for Lynn, which is the notebook we should be using to check the indications for the impact of rolling cadence on other science, on other issues? Thanks.
Yeah, sorry. So I said to Meg that I would put a list in Slack about like the different notebooks for the different questions. And then I started to paste it into the wrong channel in Slack. So and I didn't actually get to the rolling cadence notebook, but I will put a list of like, here's the different questions that the notebooks at the like SCOC question level in the Slack. And I will do this as yeah.
Thank you very much. I apologize for coming to this late. Thanks.
And we hope that these notebooks will really help you sort of navigate these simulations and the questions and how we got to the simulations from version 2 point whatever in the breakout room. So at any point in the breakout room, if you feel like you need a notebook and you don't know where to find it, you know, we'll have a list, but absolutely feel free to interface with us and ask us. Meg?
So I just feel like I need to reiterate the point as a science collaboration chair that I feel like there's two messages that are coming in and they're a little contradictory. You're saying we don't need to do all this by the end of the year, but then you're like, but we're going to do some decisions next month, so use this. It would be helpful to have an idea of what roughly you think, whether that's tomorrow telling us what is it that the SCOC thinks they're capable of getting to, because as a science collaboration chair, I don't know if I should go run and look at that simulation that it has the better NEO twilight survey or not, because I don't know if that decision matters for December or if that's completely punted or not. And so I think just a little bit more guidance, if that can come tomorrow, that would be really helpful, because people are sort of trying to figure out whether they need to dive into the notebooks after this session coming up to give feedback that goes into those future simulations. And so if you can just, if there's some way to give a little bit more detail tomorrow, that would be a little helpful, I think, in terms of helping to organize my collaboration of just, we don't know what decisions necessarily, because you said there's some low hanging fruit, which is the exact low hanging fruit the SCOC thinks they can get to and whatnot, just to help in the next month of what we as a community should be doing or not doing, because those other decisions will be punted, right? Or if it matters now, because we found the bug that was in the twilight survey by looking at them, you know, this week. And so sometimes that rapid iteration is helpful. And so a little bit more detail, if possible, would be really helpful for tomorrow.
I see Lynn's hand is up. So Lynn, do you want to address that?
So actually, and then Mike said something else that was actually very helpful. So it's a tough problem because it does become a bit of an iterative process from our point of view, but we can't talk to the community in an iterative way, like to say, oh, we did these simulations, what did you think? Because that's too hard on the community. And that's why we have the metrics, which are in math. You know, then it does help to have more people having a look at them to say, hey, wait a minute, this actually isn't in line with our expectations. what I was actually wanted to say beyond that, though, I mean, that's a really good point about like more eyes help find more bugs, and that's always going to be the case. At some point, right, things are going to go over to operations, and the SCOC will be having to make updates to the survey strategy as time goes on, and that process is also not clear. But I do think like there's going to figuring out what to do about that, and like what kind of changes the community is okay with the SCOC just making is maybe a thing, because they're going to have to make some decisions independently, right, without necessarily like taking full impact from everybody, and that is not my place to decide, because that's an SCOC question. But I do think that understanding that a little bit may be helpful to answering your question too.
Tomorrow
Yeah,
we can also go over. Sorry, tomorrow we can also go over the questions one more time and clarify which ones we think are fairly close to convergence and which ones are not. Just at a high level, we mentioned that the deep drilling fields, we do need more information. We mentioned that some of them have interplay of multiple parameters that we're optimizing jointly, and those do require more iterations. So at a high level, if you heard that the particular question that you care about is compartmentalized and doesn't affect the rest of the survey, it might be easier to get to convergence with that between now and December. If you heard that it is a complex question that requires multiple parameters to be optimized jointly, or that affects the wide fast deep, then it might be harder.
Yeah, I understand that, but I think giving more feedback will be helpful. And so again, I think understanding when those decisions stop being community-wide will be helpful, so we know as well. And so I think the more detail that, again, if you can give it tomorrow or sometime soon, that will be really helpful to understand what as a science collaboration chair I should be doing, or whipping people up, or what to be doing, because there's a eagerness when simulations come to look at them because we think we need to be giving feedback. And if simulations are going to continue to be made, but we don't need to give feedback, it's helpful to know, to tell us that you don't need to give us feedback on these right now.
So the easiest way to have an iterative process, which is hard, even in the easiest way, such as the one that Lynn has suggested, well, there's kind of two, is to interact on community and to speak to your liaisons and make sure that you have a strong connection to the SCOC through your science collaboration liaisons that lets you know, we are working on this parameter and we're making new simulations. This is a heads up, or we have made new simulations. And then if you have any feedback on those simulations, that liaison can bring them back to us, whether they're in the form of something that you want to write up or a conversation that you have with them, because in order to limit the burden on the community, we're trying not to specify the format too much. The same format might not work as well for all groups.
Just to push back on that a little bit, it would be really helpful if it's not the liaisons having to take the burden to be the sole communication of the SCOC. And so really having community posts from the full committee, because that way you can send a link and it's there. And it's because I think sometimes that's been a concern of it's one person and that person has to be the relay back and forth. And so right. Again, if there can be more general posts, I think as a science collaboration chair, that's helpful because I can send the link rather than having to forward emails from someone who's writing an email to summarize what's going on.
I encourage all the members of the SCOC to flag any new piece of information that they think is worth community posting, and we're happy to do it as a group. And again, the first community is really a great place to have a conversation about this asynchronously that doesn't burden any one person. Any other questions? So we made it to the official time for the break. Let me just take a quick look on Slack. If anybody has posted a question on Slack and they feel like they would like it answered real quick live, I see most of them have multiple replies. So unless somebody raises their hand, goes in 3, 2, 1. We're going to move on to a quick break, which I don't remember how long it's scheduled for. So let me just look at the agenda for a second. I think it's a 15 minutes break. Oh, no, we have another 15 minutes before the break. We're way early on this. We can take a long break. We can also take a long break, but commit perhaps for the next 15 minutes for the SCOC members to stay in the room and have an informal conversation with anybody that wants to ask a question. And we will reconvene as a group for another presentation at 10:45. Then we'll go in more detail about the performance of the current baseline of the simulations that we have recently produced as it compares to the earlier simulations. And then we'll let you break into breakout room for discussions. I actually can also make the breakout rooms right now. And in fact, maybe these 15 minutes are going to be useful to organize the breakout rooms. I'm going to make the breakout rooms as a default by science collaboration. And I'm going to make that now while people may want to continue converse or move on for the break. But if you think that you need a different grouping that is not science collaboration based, then let me know and I can modify a breakout room or make another breakout room. I will make the breakout room such that you can join whichever one you want, of course, and they will be labeled by the name of the science collaboration. So make sure that you're back here at 10:45, whatever time zone you're in, but 45 past the hour, that will be 10:45 Pacific time, and we'll resume the presentations then. Peter, do you think I should make a breakout room for you and Lynn separately? Peter and Lynn, sorry, Lynn, I didn't see you. I thought you might have stepped out. A breakout room where you hang out, or maybe you just hang out in the main room and people come back here if they want to talk to you directly.
Yeah, whatever.
Okay. 12 rooms are now open, 8 science collaboration rooms and 4 additional breakout rooms. I set them up to allow you to choose them. Can perhaps a member of the SCOC test it and see if they can join their favorite room and report back to me that everything worked or didn't? Thank you, Franz. I saw you disappear.
Yeah, I just tried it out. It worked fine.
Awesome. Thank you so much.
Yes, it works.
Good. I see all the science collaboration members, the SCOC members testing. Thank you. Appreciate it very much.
It worked.
Rania, I think you can wait to join the breakout rooms. I think, are you still here or did you go into the breakout room?
I'm here.
Hi, I think you can wait to join the breakout rooms. We'll use them later and officially I will ask you to join the desk breakout room after the next presentation. But for the moment, I just made them up informally if people want to separate and have a conversation separately from the group.
Thanks.
Yes, I did see the ghost in the room, in the breakout room panel. It is probably a Halloween feature.
Sorry, I just popped back in. Are we joining breakout rooms? Is that what's happening?
The breakout rooms are open if people want to separate into smaller discussions, but not officially yet. The break ends at 1:45. We'll have one more presentation from Lynn comparing the performance of the different OPSIMs. And then the breakout rooms will be official, and we'll ask everybody to join a breakout room and discuss in groups. Shailene, and do I pronounce your name correctly? Would you
Hi,
like to? Hi,
yeah, it's Shaylin. You're close.
Shailene, good. Would you like to step out in a break room with me and we can try and fix your Slack access problem?
Sure.
Then you can share your screen and we can look at what's happening. Okay,
Okay, sounds
let's
good.
go to additional breakout room. Let's go to the very last room on the list. I think it's additional break room 4. I don't see anybody there right now.
Sorry, Fed, I just sent you a Slack message to respond to. Sorry for the short notice.
Yes.
Yeah, I sent you a message in the direct messages. If you get a chance to answer that, that'd be great. But
Okay, I will. Yes, I'll
Thank you.
step into the breakout room, but I'll answer it. Yeah.
Cool. Thanks.
Which one is it? Which one did I say? 4, right? Yes. Hello, sorry, I was muted. Thank you, Sarah, for letting me know. We're starting momentarily. I'm just waiting for Lynn to get ready. In the meantime, if while we wait, if Lynn is here, perfect. So we don't have to wait. Hello. Lynn, take it away. We have about half an hour for this presentation and then breakout rooms.
Okay. Let me share my screen and get all this sorted again. Thank you again for that pointer. Well, and there we go. Yeah, there we go. That's working, right? Yes.
It's still loading, but it's on its way to work, I'm sure.
Your screen sharing is paused. Oh, you know what? Let me, I think what I did is I didn't give it enough time to click the screen and then it was. Okay, sorry. Zoom. Share.
As before, keep the questions coming on Slack. We'll try to address them on Slack directly. And then at the end of the presentation, we'll have live questions and you can bring those questions back if you don't feel like they were answered to your satisfaction on Slack.
Oh, now it's like, doesn't want to let me view screen the slideshow.
We do not. Try again. Try slideshow.
Because it's telling me my screen sharing is paused.
You know, why don't we just give up on the slideshow and maybe we just try to remove the sidebar. So exit out of here because we see a black screen.
Yeah. Did you only share one window? Yes, I thought I did, but here, let me. It may be that it's like.
She's suggesting that you share your entire screen, but you might have multiple screens, so that is possibly also complicated. I
think I understand what. Yeah, it just doesn't want to do that. Never mind.
No, we can just go without the screen share. I don't know if anybody knows the way to remove the sidebar that is a little bit distracting and wants to put it in the chat real quick. Otherwise, this is good enough. I think there must be something in view, but I can't identify quickly what it is.
That one.
Oh, that's better.
Make it better.
Yeah.
All right. And I will point out that you can view the slides and I will put that right here.
We'll add the slides on to Slack. Actually, at the end of your presentation, on slide decks, we can add them to Slack and pin them. So if somebody wants to retrieve the slides, they can do that.
Okay. So.
Oh, sorry. Just one more thing. If you go to the bottom of that column of slides and you click on the left arrow, I think that will collapse it and it will look almost, see, there you go. Basically, you're in presentation mode.
All right, close enough. So thank you again to the SCOC. And now he's going to talk about some of the outcomes from the survey strategy changes that we've had. And so thank you again to the SCOC and Peter Yokin, who's run so many simulations and so many metrics. And this is all really interesting and good stuff. So let's, yay, okay, good. So as Fed mentioned earlier, from V1, the survey footprint that we had as of like 1.7.1 and all of the V1 runs was modified as part of the movement to V2. From V1 to V2 was basically the adoption of the phase 1 recommendations. And you could think of these as the big questions being addressed was, what should the footprint be? The footprint was modified to include more low dust extinction area, which actually has added more area to our overall survey footprint. because it's more low dust area, but that means there's more more area that we needed to then put back in like sort of lower numbers of visits. And so that was one of the big changes in phase one. Another modification was that the pair strategy went to using different filters as part of each pair. So instead of very early pre-V1 simulations, we tended to do the pairs in each, the visits in each pair in the same filter. Now they're all in different filters. That has a small cost in terms of slew time because we have to do more filter changes, but it does have a huge benefit in payoff in all the transient signups. The other addition was the rolling cadence. So as of V 2.0, all of the baselines have a 2-band, half sky rolling cadence added. This was done both to explore a wider range of timescales. So you get a tighter timescale when part of the sky is active, but also and then you get a lower timescale on the rest of the time. But so it gives you a wider range of timescales that you can sample. But it also was added to mitigate the effect of adding that extra area, because with the extra area, we now have slightly fewer visits per pointing. That meant the cadence between visits was slower. And so adding the rolling cadence in meant that we could boost that cadence back up during the active seasons. As a result, the footprint and the rolling cadence together generally improved most metrics. There were some that fell. So in this, on the right is this radar plot. You see the blue line here, which is what things are being normalized to, is actually the retro baseline V 2.0. So that's the 1.7, the V1 footprint and no rolling cadence. The orange line is the old footprint, but with rolling cadence. And then the green line is the new footprint and new rolling cadence. So you can see that by adding the footprint, so that's the orange line to the green line, some of these metrics decreased a bit, like the number of visits per pointing in the low dust wide fest deep went down a bit, which drives down parallax proper motion slightly. I will point out right now, just though this circle here is the 0.9, so a 10% difference. So these are small differences. However, doing so increased a lot of these metrics, like the 3.3 by 2 point figure of merit for dark energy, increased the number of supernovae we could find, increased the kilonova that we could find. The new footprint, because there's more coverage in the galactic bulge as of V2, pushed XRB detection and microlensing completely off the scale here. So we're doing much better. Some things did fall. So the detection rate for strong lenses, that's this one here that fell. And this is falling as a result of the mean cadence. So as the thing with the strong lenses is they don't benefit from rolling cadence, because getting higher cadence in 1 year, but then a lower cadence in the next year just means that they, maybe lost that lens, because the low cadence years are also really important. So the mean cadence falls with the bigger footprint. So this metric falls. And the other things were things like the number of the brown dwarf volume. I think that's now actually gone back up in V2.9, so that's nice. And then you see other things started to do much better. Oh, so the number of stars. So this fell a little bit, and that's because we've moved the edges of the Milky Way coverage out a little bit, so you get a little bit less coverage in that high dust extinction area. That's this right here. Okay, so going from V2 to V3, these are the phase 2 recommendations. I see these as overall, they're actually kind of, many of the questions are slightly finer tuning, and maybe a little bit less overall impact than in phase 1, with the exception that this is an area, this is now the time of like enabling some particular science goals because we're zeroing in on these last few percent kind of things. So there's the big questions are relating to footprint and the filter balance, the intra-night cadence and rolling cadence, microsurveys and deep drilling fields. And I just wanted to take a moment to point out in phase 1, we all looked at about 200 simulations between 1.5 and 1.7. And that's a lot. And in phase 2, there were even more. There's about 500 simulations. And many of these, I think, were like finer grained evaluation of the specific questions. So for example, we have 48 simulations looking at the footprint and mini survey fractions of time alone. And so this is a huge amount of work, and I thank everybody who's been contributing to that. And so, you know, when we're looking at a very few number of simulations from this point onward, it is actually a lot of progress as well. So now we're at 2.99, and we have these 4 draft simulations I introduced earlier and that Peter walked us through. As we pointed out, we're not quite at V3, but we're, you know, a lot closer. And we're attempting to incorporate the SCOC recommendations. And these 4 simulations are also trying to show, again, where there's still some uncertainty. And as Peter pointed out, we're already finding ways after releasing these 4 simulations where we could do better. So the filter swaps, for example, swapping U, Z, and Y, not just U and Z. I had to look at the supernova recovery rate in the deep drilling fields, and this does improve the supernova recovery rate in the deep drilling fields. So this, we still haven't looked at this in terms of the rest of the survey yet, but this does seem a promising change. We have the deep drilling cadences to look at, and the you know, these issues with the twilight and, you know, microsurvey. And so this is a bit of an iterative process, and how we can work on that through to the point where we can say, okay, yes, these are the simulations that we would like to take for V3, whether it's just one or whether it's a few by the end of the year is a good question. And I'm happy to talk to everybody about like what is a sustainable way to do that. And looking back at the high level you know, these high level metrics between these runs. So now again, V1 is the blue circle. V2, like, so with the footprint, with change, with the rolling cadence, is the orange line now, and the green line in this case is one of the V2.99 simulations. So you can see one thing is that between 2.0 and 2.99, the patterns tend to be about the same. We're not necessarily making huge changes. They're sort of like more iterative changes on what was already there. And I'll talk more about what changes you do see here in a little bit. And then this is a radar plot. So those same high level metrics across all of those 2.99 simulations. So this is just the 2.99 simulations. And you can see that there is like clearly still to be done. Just the things that we already talked about as far as making it better, but also you can see like this low galactic plane simulation is not the best option for refinement of the galactic plane footprint. I would point out, it does actually reduce the galactic plane fraction survey time to more closely match baseline 2.2. So this is not the option we should choose, but maybe we should choose something that starts to move towards this, but not towards this, but like towards reducing some of the time that we're spending. And maybe that's just narrowing down that footprint a little bit more. Okay, so general high level metrics. In the 2.99 simulations, the footprint is mostly the same, but we do have this different footprint in the galactic plane, and we do have extra time that we've committed to deep drilling fields, and we have added the twilight microsurvey. So what changed and what gave up? So we did drop the North Ecliptic Spur visit slightly. And we have an overall decrease in the Whitefest Deep number of visits. We can probably tune this a little bit more. Results are probably likely to be consistent within a few percent. Even now, these changes are within a few percent. So over here, this is the footprint. On the right is just a histogram of the number of visits per area in all bands. And the magenta line is a very busy plot, I'm sorry, but the magenta line is the old DIR 2.2 baseline. And you can see that there's a big peak here, which has now been split into two. This is previously the galactic plane background and the North Ecliptic Spur had about the same number of visits. And now you can see they're slightly starting to diverge. This peak is where we threw the galactic plane bulge at a much lower fraction. And again, that's probably not something we can do. But you can see that the Whitefest Deep area here, there is some variation among these runs. It's not a huge amount. So again, higher level metrics. These are just showing you in the Whitefest Deep area, the median number of visits per pointing across the sky, the median single image depth, and the median co-added depth. And then these are the SRD metrics about parallax and proper motion and the number of visits per pointing. So what are we showing here in these colors? Blue is good, red is bad. This is V1, this is V2, and this is V2.0, and that's where everything was normalized to. From there, everything is a fractional change. If it's a magnitude, it's the change in the magnitude. So you can see from baseline 2.0 to 2.2, we actually made some improvements in our single image depth. I think this is because we added some preference for good seeing images. But anyway, clearly we were doing something nice here. And then most of this improvement in the single image depth has carried over into all of these 2.99 simulations. So that's good. The typical number of visits per pointing, the median visits per pointing, is about the same across these V2 series simulations. And then it drops in the 2.99 simulations, as would be expected. And then the co-added depth just kind of is a reflection of the combination of both of these. One of the things that I would point out is that from 2.0 to 2.1, and carrying over through here, we did have a slight reduction in the U-band depth, and sometimes in the G-band. And I believe this corresponded to when we updated our sky brightness files, and it's just a slight response in the in what's going on in the scheduler and where it's choosing observations. This could be something, I think this reflects reality in terms of like what the U-band sky brightness is and what it is. But again, these are the kinds of things that we would need to fine tune when we get more information during commissioning. All right. So, and then looking at the actual science metrics for these sets of runs, we see that many things are actually the same or improved, especially if you compare to V1. So V1 all the way over here, there's some things that were really terrible, and then they got better, and then they got maybe even better with most of the V2 simulations. You can see where these metrics are for objects which are concentrated near the galactic plane, and then they really dislike the low galactic plane footprint. So many of the improvements you see kind of show up in the V2.2 simulation and then get carried over. And this is because we added in V2.2 a slight version of the suppressed revisits. So this is taking visits that were happening in the same night and kicking them out of that night and putting them in a different night, which tends to happen to be nearby. So by doing that suppression of revisits, even at a very low weight, it improves a lot of different metrics. And I think this has been very helpful. And you can see that change if you look at some of these TGAPS percent metrics, which are just measuring the fraction of overall visit gaps, so the time between visits that fall into these time periods. So the solid lines are the fraction of visits that fall into a 2 to 14 hours interval. And you can see in these are all the 2.99 simulations, and they all have a boost in that because we added those low frequency long gaps triplets. Now I will say this number looks a lot bigger than these numbers by a factor of 2. These are still a small overall fraction of visits that have time gaps in that percent in that interval. So this is a big improvement. It's still not a lot, but it's an improvement. And I think this is actually going to be helpful for overall time sampling. The other thing you see is that the number of visits that happen to fall within one day it improves, and it improves a little bit more with this roll early simulation, because this is where we put a little bit higher weight on that suppressed revisits basis function. So we're kicking them out of the same night a little bit more strongly. So the SCOC, one of their recommendations was, boost these values in particular. And I think that looking at these and then looking at this plot, which shows, hey, we started improving metrics when we added this suppressed revisit, has actually been a good move. If you look at those same overall metrics with a large set of runs, so these are runs that are looking at when we were adding rolling cadence in various forms. So this is the 2.0 rolling cadence, where we did a range all the way from no rolling to 6-band rolling cadence. And the 2.2 simulations, where we added rolling cadence most only in like none or 2 or 3 bands, and then with some extra variations. There's very little modification between in the metric results between 2 and 3 band rolling cadence at these 10 types of strengths. And then these are the long gaps when we added the long gaps. And these are where we added the suppressed revisits. So in general, you can see there's some tension perhaps between 2 and 3 band rolling cadence, like this metric versus this metric, for example. And you see that here too, as the rolling cadence increases and decreases. And so this is where some of the uncertainty with the SCOC in terms of 2 or 3 band rolling cadence is coming from. A lot of this is alleviated if we can do a 2-band rolling cadence with the suppressed revisits in the same night. And then especially if we couple it with the long gaps, a very infrequent night, operation active fraction.
Sorry, just to clarify, that is in fact our current recommendation, except we still need to fine tune what are the parameters of the suppressed repeat and
yes. So as of last Friday, that is indeed the SCOC recommendation. So yeah. So again, coming back to these high level metrics going from V2 to 2.99, you do see some that are falling. And in particular, there's the local volume dwarf metrics, which are falling. And when I looked at the actual numbers of these, the actual change is very small. So the value, for example, that this is finding outside of the South Celestial Pole area, this local volume dwarf be greater than -6.4. This is counting the area that we can see this over, or the number of dwarfs you see in this with this magnitude. It's a change of sort of around 45 local volume dwarfs instead of 48. So these are small changes. And one of the things that's a little bit hard to represent in these plots is what's the error on this number. And so I think that while this is showing red, it's a small change, and it's a small change on a relatively small number. So this is where, we would go back to science collaboration, talk to them more. Is my inclination to think like this is probably just variation in our metric. This number here with the number of young stellar objects is interesting. You can see that this falls throughout all of these simulations. One of the things that's different in 2.99 compared to 2.0 is the galactic plane footprint and the filter balance in the galactic plane. And in 2.2, the filter balance in the galactic plane is more red, and in 2.2 it was more blue. Sorry, in 2.99 it's more red, 2.2 is more blue, and the YSO metrics are looking for G-band depth. So I think this is mostly because of the filter balance in the galactic plane, and that is one of the places where we still have fine-tuning to do. There's also perhaps some impact from a slight difference in the galactic plane footprint itself. So these are things we will go back and be working on as part of that fine-tuning the galactic plane. Yeah. And Jeff mentioned in the chat that the local volume dwarf is probably due to the G-band, and I agree that that's what's going on.
Can you clarify what WL stands for? I think it's weak lensing.
WL is weak
There's a
lensing.
lot
So
of-
this is the weak lensing. It's just counting the number of visits. So this metric falls because we have the number of visits per pointing. We have fewer visits per pointing at 2.99.
And perhaps it's worth reminding people that the low GP is not an actual contender. So if you see big red marks, that's not an actual contender. That metric is designed to sort of stretch the parameter space to see how sensitive we are to it.
Well, and the fact that there is a metric that shows the negative impact is useful, because otherwise I think like you don't know that that's not a contender. So
Indeed.
all right, so what did we add? And I'm going to talk a little bit about the additions in 2.99. First of all, there's this Twilight NEO microsurvey. So if you're not familiar with why we would want to do that, the point is that this allows the study of asteroids interior to the orbit of Earth, because we're looking at very high air mass close to the sun near the twilight time. So this includes, I actually don't know how to say this word. They used to be called Vatiras. These are objects interior to the orbit of Venus, and then potentially hazardous asteroids interior to the, I think it's ILO Jackson's, but interior to the orbit of Earth. So these are things that would be otherwise undetectable in the survey. So the SCOC recommended prioritizing the Twilight NEO microsurvey to start in year 1. And one of the reasons being because of the fact that Twilight is particularly vulnerable to the pollution from satellite constellations. As Peter's mentioned, we didn't actually implement a Twilight NEO microsurvey that matches the SCOC recommendations, and we were going to go and fix that and look at the impact. However, it is interesting that while we didn't do anything that was quite what the SCOC recommended, one benefit is that we did do something the SCOC had wondered about, but not actually recommended. Partly because of the fact that they didn't have a simulation that explored this area. So, these are useful from that aspect. What you see here is the discovery rate, assuming a particular kind of discovery where we look for quads for Vatiras and these objects interior to the orbit of Venus. And you can see that in all of these simulations, we get on the order of 10 to 20 times more of these objects instead of 0, or very close to 0. And then in the simulation that we were trying to represent the Twilight NEO microsurvey version of, that would have been on the order of 50 to 100 times more. So this, I think, is an area where we do probably need to put in some additional study and see what the impact is when we increase the microsurvey time to what it should have been, and then where we actually want to end up. Oops. All right, so the other additions and modifications, the deep drilling fields. So the SCOC recommended increasing the deep drilling field time above 5%. This will allow better supernova 1A discovery, amongst other things, and achieving 10-year deep drilling field depth in the Cosmos deep drilling field within the first few years. So over here, this is a plot like Peter had. This is in baseline 2.2. So where we just did the deep drilling field at 5%, and Cosmos was the same as everything else. And you can see these are the nights. This is the number of observations. It just kind of goes up, up. So that when we're observing in the season, it's operating. When we're not, it's not. It's just fairly even. And this is in one of the simulations where we have now, where the overall fraction of time is about 7.2%. And you can see this is Cosmos. So you can see it's getting, this is about 10-year depth in Cosmos. It's getting to that point early on, and then continuing to observe at some reduced rate. And this is one of the other fields, which is just operating more like a standard deep drilling field. Looking at the metrics within the deep drilling fields is kind of necessary to evaluate what the impact is. So as Peter mentioned, in baseline 2.2, we added pre-scheduled deep drilling fields. So in 2.1 and 2.0, they were the older style deep drilling fields, which just kind of kept going at a standard cadence, didn't try to schedule themselves around the lunar cycle. As of V2.2, that was not the case. So you can see that some of the bands were not doing so well without that aspect. And in general, they're all doing better in 2.99 because of the fact that we have more time. This is this block up here is not actually a deep drilling field. This is an area, a random area that we choose in the wide fast deep to compare, like, oh, okay, this is what's happening in the deep drilling fields, this is what's happening in the wide fast deep. And as expected, the co-added depths in the wide fast deep are less because we have fewer visits. In all the deep drilling fields, they are more, except for this one, which is the DD6 run, where we only do about 5% of time in the deep drilling fields. But we're still doing Cosmos to 10-year depth early. So Cosmos is kind of sucking up a bit more of the time here. And so some of the fields are a little bit less deep than in the 2.2 baseline, where all of the deep drilling fields were even. So the other thing to note is in these simulations, the cadences within the deep drilling fields are just fairly simple. The seasons are around 200 days. They vary between 150 to 200 days, depending on the field and which season it is. And there's gaps around full moon so that the depth doesn't fall below G of 23.5. This, I think, corresponds to a gap of about 7 or 8 days. So what does this do for the supernova? So these are, this is actually not a relative plot anymore because of the fact that there are fields. The supernova metric has fairly tight constraints. And so I think that the constraints are very tight. They match what the desk believe that is very feasible to do for science. What it does mean is that some of the deep drilling fields actually don't find any supernova that fit this constraint, especially in the older baseline simulations. So when the total number of the total fraction of time in the deep drilling fields is about 5%, then we tend to not get supernova. And when it's more in these runs, not this one, that's the 5%, then we do find more supernova. And what you can see is the Cosmos field, getting that deep depth early on, is very, very happy. Both the depth is greater and the cadence is deeper. And primarily what you're seeing here is the cadence being tighter. And the number of supernovae increases. The redshift, this is the redshift values. And again, remember, these are not relative, these are absolute values of what's returned by the metric. The median redshift for the supernova is still not as deep as the desk would prefer, but we are doing better, and again, better in Cosmos. So Cosmos is getting above 0.6, and the other fields are generally landing somewhere in the range of 0.5. And you can see here, like this, while the wide fast deep field finds supernova, it does not find them at a very high redshift. So this is interesting. So we're doing better, but modifying the sequences and the frequency of those sequences can modify the Z-limit and the total supernova detected. More frequent sequences do better at detecting supernova. Longer sequences, so there's greater depth in a particular night and an epoch, can increase the sensitivity to higher redshift supernova. And this, additionally, this swapping U for Z and Y instead of always U for Z can also help find higher redshift supernova. This is an area where we definitely have a lot more optimization to be done. From the V2 series, or V2.2 simulations, we did actually run a lot of different options on the deep learning field cadence. And some of those look pretty promising. And what you see down here in the brown spots are what we've done as part of the these V2.99 simulations. But you can see we could do better with something like quads, perhaps, although it's not higher redshift, it's more supernova. And those are not even taking more time. So there's definitely room for improvement here. So let's wrap it up. The phase 1 recommendations were great. I think they led to an improvement in many important metrics due to shifting the footprint and adding rolling cadence. The phase 2 recommendations, in my view, will slightly shift the cadence, allowing more sampling at a wider range of timescales, and they'll fine tune the footprint. They will also add these recommendations on how to spend time with the mini surveys, like the DDFs and the micro surveys, like the Twilight NEO and TOOs. And then early, in the next year, we'll see early science and optimizations based on commissioning information to happen. So what I would hope that we can learn about as soon as possible, like definitely we want to optimize these, and we have room to improve. But especially, I think we need to know, are there deal breakers we haven't seen in these that are present in these 2.99 runs? And like I said, I do expect updates to the runs in this 2.99 set, and I very much like to talk to the community on how we should try to handle that. In general, I do expect V3 to look similar to these runs in most aspects, but with variations in these tweaks that we've already talked about. And then
Thank you, Lynn. That's awesome. Thank you, Lynn. Thank you so much. A round of applause, virtual and physical. We're running a little bit behind schedule, and I want to make sure that we do make this space for the community to get together in small groups and discuss. There were a lot of questions on Slack that have been answered synchronously. So I propose that people split into, go into the breakout rooms that have been created. The way you do that, you click on the breakout room button, and the name of the breakout room that you may want to go to is the one of your science collaborations. If you don't think that you want to have it, that you have the right space inside of the one of the science collaboration rooms, stay back. And I can change the name of one of the extra rooms. There are 4 extra rooms. And yeah, I think that's it. And if you have some questions that were not answered completely on Slack, and you want to stay back, we can answer them. I think the plan is for Lynn and Peter and myself to stay back into the main room, and for the liaisons that are present in this call to join the breakout room assigned to their science collaboration. But like I said, we can redistribute if there's the need. Any questions on the process?
Are we reassembling after the breakouts, or that's for tomorrow?
I think that's for tomorrow. So I think the only thing that we will do is signal that this is the end of the official time. We can even leave the Zoom open until people roll out. Technically, the workshop ends at 1, and then we'll meet again tomorrow. And there will be again. I want to emphasize, we want to hear what you talked about in your breakout rooms. So please make sure you assign a scribe and a person that will report back. That will be the last session tomorrow. Any other questions on the process? Any questions that you didn't get the chance to put on Slack that you really want to ask Lynn right now? Then I invite you to join the breakout rooms.
Before I leave for breakout room, I just wanted to thank, like virtually but in person, Lynn and Peter for all the help they've given me, and everybody else. It's been very useful and very educational for me to get up to speed in a lot of this stuff. I've had a lot of fun doing it, so thank you very much.
And you know what, actually, I'm going to take this opportunity to say thank you to you, because for all the people who Conda installed RibbonSim, you have.
Yeah, that. yes, that was me. Happy to help with that always. So I'm gonna go to the breakout room now, but thank you guys.
Thank you, and it was great input. The input that you provided was extremely useful to the SCOC. Thank you so much.
Thank you.
Thank you, Lynn and Peter. The presentations were great. I know that it must have taken an enormous amount of work to put them together. Thank you so much.
You're welcome. Thank you.
I'm gonna go in momentarily into each one of the breakout rooms and see if people need anything. Like I said, I think you and Peter staying back is probably the best idea, unless you're called by somebody to join the science collaborations. And then, Lynn, can I make you co-host? I will need to step out a few minutes before the end.
Sure. Can I go into a breakout room if I'm co-host? Because Timo did ask if I could go back and chat with the.
Yeah. You can go. You can. In fact, I'm gonna make you a host, so you can do everything.
Okay.
You'll have all the power. I'm gonna do that right now. Where are you? More. Make host. Oh no, that's wrong person. Because the people are moving in the breakout rooms, the names are moving, so I'm having a bit of a hard time. But I think I got it. Did it tell you you're the host now?
Told me that Lynn is the host now.
It says I have all the power. I'm gonna if I make somebody else co-host, then in case my internet connection drops, it's good, right?
Yeah, you can make me co-host, and you can make maybe Peter as well co-host.
Yeah. Me.
I sent you a Slack message, Federica. I'm
gonna look at it.